And what is semi-structured data? Semi-structured data means the structure is defined. Okay, you have defined a structure, but it's not mandatory to follow the structure. Okay, that kind of data can be known as semi-structured data, or you can call it as loosely structured data. So we are having the structured or unstructured or semi-structured data. So the example for semi-structured data is an XML file is an example for semi-structured data, or an Excel sheet is an example for semi-structured data. So coming to the unstructured data, the flat files is an example for unstructured data. Flat files means what? The plain text files is an example for unstructured data. What is a structured data? Yes, rows is defined, columns are defined, constraints are defined, keys are defined. That kind of data we are calling it as a structured data. You take the data which is in RDBMS is an example for structured data. Now see, what is a big data? Big data is a huge amount of data. So the data can be in the size of giga, tera, peta and exabytes of data. And the structured or unstructured or semi-structured data. So we are having this kind of data. Now fine, when your data is in a structured way, right, it's easy for the processing because a constant is defined, a primary key is defined, so that you are going to analyze, you are going to identify all the tuples in the relation. But when it is coming to unstructured data, you wrote something in a text file, you wrote something in a flat file, and if you are trying to analyze the data, right, how much difficult it is, because there is no constraint, there is no structure is there. Simple, you are writing the data into the plain text file and you have given that file for analyzing the data, right? So, and that is unstructured data. It's a very much difficult to process the unstructured data, right? Semi-structured, yes, you have defined a structure, but it's not mandatory to follow the structure. So you can say it's a loosely structured, or you can call it as a semi-structured data. Okay, so when we are having the data is unstructured, we can say that the data is consistent. No, the data is inconsistent data. We never say that the data in a big data is accurate data, because when it is an unstructured data, always it leads to inconsistent data, always it leads to inaccurate data, right? So when it is coming to the unstructured data, right? So now what we do with big data, why we are discussing about this big data these days, why big data is that much of popular? I'll give you one example, right? We people are very much habituated in the shopping over online. Every day we are buying on the Flipkart, Amazon, eBay, Walmart, right, Best Buy. So we are buying the products. I'll take one example here. Suppose the data we have something like this, a product name. Okay, so this is the data set. Suppose I'm taking that product underscore info is a file. Okay, so the file is a product underscore info. You can take it as it's a product info.txt. So it is a plain text file which is an unstructured data. Okay, so in this text file I'm writing the information. So product name and user name and the time when the user visited the product, right? So suppose now I'm writing the product name iPhone 6, right? So username, some Ajay is a user who visited this product on some date, right? So we have a time. Now we have a data set like this. So consider there are some 1,50,000 entries are there, right? Right, so there are 1,50,000 entries are there in the file product underscore info.txt. So this text file contains the data like the product names, name of the products, and the user who visited this product and at what time this user visited the product, right? So now so it contains some information, something like, right, so up to 1 lakh entries we are having. Now so here issue is iPhone 6 Again visited by Ajay in some other time, right? So he visited in some 11, 12, so 13, right? This time he visited. So on the same day he visited the product, right? So now, so in the entire file in this particular day, Mr. Ajay visited this product 55 times, right? So Ajay is a user. In the day in March 2nd, he visited the product iPhone 6 55 times. Right. Similarly, so there are the many users who visit the products multiple times, right? So there is no restriction that each user has to visit the product only once, right? It's up to the decision, right? He can visit the product before purchase. He can visit the product any number of times. So Ajay is exists 55 times. You take Srijit is 30 times. Any other one, Ramesh is having 40 times, right? Any times we have any number of times he can visit. But whenever you are trying to analyze the data, my question, your project manager raised a question. Yeah, Mr. Ajay, now find out how many users, okay, visited the product iPhone 6. Now you have to generate a report. You have to find out how many users visited the product iPhone 6. Now you have to analyze the file with the name product underscore info.txt, where you have a product name iPhone 6 and you have the username. Right. So when you're writing the query for this, how many users visited? Right. Now, how many entries are there? 1,50,000. So can you give the answer like, so 1,50,000 users visited the product iPhone 6? No. Right. So in this 1,50,000, only Ajay exists 55 times. So in this example, even though Ajay user ID, Ajay is a user, he exists 55 times, you have to consider him as one user. Even though a user visited the product multiple times, his name exists multiple times in the data set, but you have to consider him as a one user. Right. So when you're writing the query, how many users? So you have to consider, so the multiple times how repeated username, right? Ajay can be treated as only one user. If you write another query, how many times each user visited the product? This is the query. Now before purchase. Now, if you want to find out how many times each user visited the product, now Ajay is a user. He visited the product 55 times. Now, for this query, you have to consider Ajay as a 55 times. Right. So this is how we are going to analyze the data. This is only the thing which is possible with analyzing the big data. This is only the thing which is possible with MapReduce. Apart from the MapReduce, we cannot analyze the best way such kind of queries. So we have a big data, and to analyze the big data, we are using a framework called Hadoop. So I'll tell you how we do in Hadoop later. But see, as of now, see, these are the two different queries where we are treating the data in a different way. Right? So this is how we are going to analyze the data. Suppose I'll give you another example. You take a telecom sector. Right? So there are the two persons are available. One person is XYZ, other one is ABC. Right now in India, we have MNPs there. So any user can shift to any network. Right? So now you have to treat every customer based on his request. Suppose you take ABC is a user who messages every day. XYZ is a user who travels frequently. Right? XYZ is a user who travels frequently. So when you're adding a new product, when you're adding a new plan, when you created a new plan, suppose if it is a message plan, you have to suggest the message plan to ABC, not XYZ. Right? So if you suggest this message plan to XYZ, he won't use that one. If you have a roaming plan, a newly introduced roaming plan, you are suggesting for the ABC, there is a no use, right? You should identify the requirements of every user. Based on his requirements, you have to suggest the plan, right? So when you have a new message plan, give it to ABC. When you have a new roaming plan, give it to XYZ. So they will have, you can say, more personalization, right? You are giving to your customers, right? So this is why what we are doing with the big data. We have to make an eye on every customer, every user who is doing who is doing what, and how the best you can analyze the user's requirement, how the best you can give the service to your customers can be easily identified with the big data, right? So another example, say we are right, you take Flipkart, right? You have added a product in your cart, but you have not completed the purchase. Suppose you are a regular user from the last 30 days, every day you are visiting to Amazon, but you are not visiting from last 30 days. Right, immediately they will send you a message. So we are missing you from last 15 days. Where are you? Right, because how many users visiting, and they have to identify every user who is doing what and what are their requirements, what are the personal choices of each and every user. So these are all the things which are possible with big data. So what is a big data? So big data is huge amount of data. It's a structured, unstructured, semi-structured data. It's a petabytes and exabytes of data. So there are millions or billions of people are involved. So there are billions and trillions of records. The data is loosely structured or often distributed data. So there is a complex interrelationships with the data. Right? Every transaction is specified with a timestamp. So we say our data is incomplete, inaccurate data. Right? It's a big data. Now, what we are doing with this big data, right? We have to apply the big data analytics, right, to the big data. Here, suppose, right, we have the big data is there. We have this much of data is there. Now, we need an environment. We need a framework to work with the big data, right? So, the environment, so to work with the big data, you can use SAP HANA to work with the big data, or you can use Oracle's Exadata, or you can use Teradata, or you can use Hadoop from the Apache, right? So you can use SAP HANA or Oracle's Exadata or Teradata or Apache Hadoop. So these are the frameworks which are available to work with the big data, right? So if you take SAP HANA, you need to have a separate hardware, you need to have place, you need to have an application engine to work with the big data. You have to buy the license, you have to pay for the support, right? The same thing for Oracle Exadata. You require a separate hardware, you need to have an application engine to work with the big data, you have to buy the license, you have to pay for the support, right? Similarly, it's same with the Teradata, right? So when it is coming to the Apache Hadoop, right, coming to the hardware, Hadoop supports commodity hardware, okay, and you can use any application engine to work with the data, right? You can use any app engine to work with the big data. License, open source, so it's a free way, and pay for the support, uh, sometimes no, or if you are using the distribution, it is S. It's your choice, right? So now, see here, to work with the big data, so we have SAP HANA, Oracle's Exadata, and Teradata, Apache Hadoop. So these are the frameworks which are available. So now coming to the SAP HANA, right, you need to have separate hardware, you need to buy the expensive storage machines which is much costlier, uh, to right, expensive machines, you need to buy the application engine, you need to buy the license, pay for the support, right? The same thing for Exadata, the same thing for the Apache Hadoop, right? So why Hadoop is famous, why everyone is looking for the Hadoop, right? How, so Hadoop supports commodity hardware. What is a commodity hardware? Commodity hardware means they are the reusable machines, they are the inexpensive machines, reusable, inexpensive, low-end machines. Hadoop never suggests that Mr. Go and buy the expensive storage machines. We are always buy the inexpensive, low-end or medium range machines, or you can use Hadoop in your existing environment. Hadoop can be integrated into any kind of framework. Hadoop can be integrated into any kind of architecture. So Hadoop is a commodity hardware. So what is a commodity hardware? Commodity hardware is a reusable machines. These are the inexpensive machines, right? Hadoop supports commodity hardware. Application engine, you can use any application engine, right? You can use Java, C, C++, so any application engine you can use. It's open source, right? You no need to pay for the license. And if you are using Hadoop from the vendors, if you are using from the Hadoop from the distribution, you have to pay for the support. Okay, see, now actually what is a Hadoop? Okay, so what is Hadoop? Hadoop is a distributed data processing system, right? Distributed data is going to be distributed processing system, right? Which is fault tolerance, which is scalable, which provides high availability, right? Hadoop is a distributed fault tolerance, high available data processing system where we are going to process the data with its components. So when used Hadoop from the Apache, so we have the two things. The Hadoop is a combination of SDFS and MapReduce. Hadoop is a combination of SDFS and MapReduce. What is SDFS? SDFS is Hadoop Distributed File System, and MapReduce is a data processing system. Okay, so now what we have in Hadoop, the Hadoop comes with the two things. If you use Hadoop from the Apache, I'm not talking about the Hadoop from the vendors. If you download Hadoop from the Apache, you'll get the two components, that is SDFS and MapReduce. SDFS is Hadoop Distributed File System. See, we people are having Windows. You are saying NTFS file system, you are saying FAT file system, right? So whenever you created a document, whenever you copied a movie into your C drive, it is storing internally in a file system, right? That's an NTFS file system. Or you take FAT file system. You take Linux is an EX1 file system, EX2 line file system, right? The same way Hadoop uses a file system called SDFS, right? So that SDFS is Hadoop Distributed File System. Okay, now so we have data processing system, that is MapReduce. So what we have to do now? First, to work with the Hadoop, we have to load the data into SDFS, right? So what we do with the Hadoop, the first thing is you have to load the data into SDFS. Then you have to analyze the data, or you have to process the data with MapReduce. Okay, you have to load the data into SDFS and you have to process the data with MapReduce. See here, why MapReduce? why it is not possible with any other environment. I'll give you one example, a simple example. Suppose in my system, see here, uh, right, see I have this number of registrations, right? So so these are the Excel sheets. So I have giving the training, so multiple users are registering for the sessions. Now I want to analyze the data in all these text file, all these Excel sheets, right? So whenever I'm starting a new batch, so I have a registration report is generated by the GoToMeeting. Now I need to analyze the data in this one, right? So whenever, so I have different users are available. Now if I want to analyze the data, so I cannot open one file and check with some columns, open a second file checking with the columns. It's not possible. And where, suppose consider if an Excel sheet contains some 1 lakh records are there, and that there are 100 Excel sheets are there, how you process the data? Suppose if you take an RDBMS, what you have to do, right? Simple, what we are doing, we are writing insert statement, right? How many times you will insert the data, right? If there are 100 files are there with the data and you are using RDBMS, now you have to open the file 1, you have to insert the records into the RDBMS, then you have to open the file, you have to insert into the RDBMS, right? No, right, in the Hadoop, what we'll do, for this map reduce, I'll give this all 100 files as an input data to my map reduce program as a job. Then the map reduce will load this data and it will process the data. So whatever I require the data, whatever the analytics I want to perform on the data, I can perform in an easy way. I can perform in a simple way by writing a simple query in Hive. I'll write a simple program in a Pig, or I'll write a Java program to analyze the data, right? So if it is a 10 input files or if you have 100 input files, we'll give all the input data as the files to the MapReduce program. So it will take the data into the files. We'll give a compression files to as an input data to your MapReduce program. Fine. So we'll see that one later. So we have to load the data. So all these files, first I have to load this into SDFS file system. Once the data is available in SDFS, now I'll make this data to be useful for your processing system, for your analytics. Okay, see now how much data we are going to generate. Right, so there are 600 videos are uploading in YouTube. There are 200 million plus are emails. This is all the data is generated in a 1 minute. See, there are there are 3 lakhs of users, sorry, 3 lakhs of US dollars are spending on online shopping in a single minute. Right, so there are 7 lakh plus Facebook updates. 7,000 photos are going to be uploaded in a Flickr. Right, there are 4,000 minutes of Skype calling. Right, so there are 2 million plus searches, Google search queries. So this is all the data is going to generate in a single minute. Now see how to analyze this big data. So what we'll do, so the big data will makes easy for us to take the better business decisions, which is useful for predictive and identifying the changes, and you can able to identify the new opportunities. So previously the data which is not yet useful, the data which is treated as a junk, now will be useful with this big data, will be an important data, will most useful in order to take the business decisions. Once the data which is treated as a junk data is becoming useful data, right, with the big data. Right, so Apache Hadoop is a scalable framework for storing and processing the data on a clusters of commodity hardwares. Right, Hadoop is designed to scale up from a single node to thousands of nodes. Right, Hadoop has 2 components. One is a computing framework and SDFS file system, Hadoop Distributed File System. right? So the computing framework, that's a processing system which we are using it as a MapReduce. So see now, see this is one in the green color is Hadoop environment. Now in the Hadoop, what we have, I told it's a combination of SDFS and MapReduce, right? And to work to process the data, you have to load everything, every data into SDFS. So these are the different data sources. It's a CRM data, or it's a web transactions, the point of sales transactions, staffing, product catalog, inventory, stores, the click stream, social data, server logs, location data. So whatever the data it is, right? First, what you have to do, you have to load the data into SDFS. You have to collect the data from the other data sources, and you have to load the data into SDFS. Once the data is available in SDFS, you can able to process the data with the processing tools MapReduce, Hive, and Pig. Okay, so now, so we are using SDFS as data storage, and for the data processing tools we are having Hive, we are having Pig, and you can use MapReduce. Right. What is a Hive? Hive is similar like a query language. It's like a MySQL, but Hive is not a DBMS. Right. Hive follows the syntaxes similar like MySQL, but Hive is different. MySQL is different. So in a Hive environment, in a Hive shell, if you run the query, select star from product underscore info is an Hive query, right? The same thing we write in the Pig. So Pig is having the grunt environment. In the grunt we write dump product underscore info. This is a Pig statement. Hive is like a query language. Pig is a data flow language. Pig is a script language. We know what is a pig, right? A pig can do anything. A pig can eat anything. A pig can survive anywhere. The same. That's what the pig program. You can write pig as a part of the script program. Pig is an individual program. Pig is an in a command line program, shell program, right? We can write the pig using three ways, as a dot pig, as a pig separate program, or we have a grunt shell where we can write the pig statements, or we can embed pig script in a Java program, and we can write a direct MapReduce program in a pig, right? So pig is having grunt. So to list the records from the dataset product underscore info, we write dump. So the same thing in a MapReduce, you can write MapReduce code, or you can write a Java, or you can write a Python to write the MapReduce programs, right? So Hive, Pig, and MapReduce, so these are the data processing tools. The one line in Hive, the one line in Pig goes up to 100 lines, more than 100 lines in a MapReduce program. So it's not all the time required to write the code in the MapReduce. You can code in Hive, or you can write MapReduce code in Pig. So if you write code in Hive, that will be taken by the MapReduce. You can directly code in Pig, right? So you can, if you are a Java programmer, yes. If you are a Python programmer, yes. Or you don't know, you are new to the programming, you don't know anything till now. Now learn Hive, now learn Pig, right? Now learn the MapReduce to work with the Hadoop environment. So you are already a programmer. You don't want to learn anything new. You can use C, you can use C++, you can use Java, you can use .NET, you can use Excel to work with a Hadoop environment. So any user can able to work with the Hadoop environment. Hadoop is not a complex programming. MapReduce is a complex program, and Hive, pig, and everything is a complex program. The flexibility is the user can code any language. It's not mandated that you always have to write in Hive, you always have to write in pig. So based on your requirement, you can use Hive, or you can use pig, or you can use Java, or you can use C, C++, or you're a .NET programmer, you can use the code for the Hadoop. Okay, so these are the Hadoop data processing tools. So if actually the Hadoop is available from the Apache, the license provided for the Hadoop is Apache. So we are Apache Hadoop, right? So you'll get only SDFS plus MapReduce and Hadoop distribution, right? Hadoop is available from the vendors. If you want to someone to support, if you want to someone to configure Hadoop, then you have to use Hadoop from the distribution. So Hadoop distribution, Hadoop is available from the Cloudera, and Cloudera is providing the Hadoop in the form of CDH, right? Right now we have CDH 5.0 with available with Hadoop version 2.0 onwards, and Hortonworks can use Hadoop from the Hortonworks, where they are giving in the form of SDP. Hortonworks data platform with the available versions Hadoop 2.0 before and Hadoop 2.0 afterwards. And similarly, MapR is giving the versions of Hadoop in the form of M3, in the form of M5, M7. Right? You can use Hadoop as M3, or you can get it M5 or M7. So these are the MapR distributions of Hadoop and Hortonworks and the Cloudera. So you can buy the Hadoop, you can buy the support from the Cloudera, and you can use Hadoop from the Hortonworks, you can use Hadoop from the MapR. Even Intel is having its own Hadoop, right? In the coming days, Red Hat is planning to release its own Hadoop, and very short we can see the Hadoop from the Microsoft too. Right. Recently, Microsoft and Hortonworks working together to provide the solutions. Right. So in the coming days, we have a separate this Hadoop environment is available from the Microsoft. Right. So these are the Hadoop distributions. So when if using the Cloudera, so you'll get some specific components. You'll get the components up to 10 to 12 components, predefined Hadoop environment they will give. Right. So they will give the right. So if you use the Hadoop from the Cloudera, so you'll get the components Flume, Cube2, HCatalog, Hue, Pig, Hive, HBase, Zookeeper, Uzi, Weir, Snappy, Mahout. So these are the components you will get from the Hadoop Cloudera. If you use Hadoop from the HBase, these are the components like HBase, Pig, Hive, Taste, Zookeeper, Hue, Storm, Uzi, Falcons, Cube, Nax, Flume, Accumulo, Phoenix, Avro, Mahout. So these are the components which you'll get from the Hortonworks data platform, right? Hortonworks. Right. So it's up to you. You can use any distribution. Just go through the documentation of how they are providing the Hadoop. So based on that one, you can decide whether you want to go with the Cloudera, or you can go with the Hadoop from the MapR, or you can go with the Hadoop from the Hortonworks. Right. So this is a Hadoop. We are having the Cloudera from the Cloudera. Right. You can run the command Hadoop space version. Right, in my machine I am using Hadoop 2.0.0 in CDH 4.4.0. Okay, so Hadoop, these are the Hadoop distributors, or you can say Hadoop vendors. So Cloudera, Hortonworks, MapR, Intel, Red Hat, Microsoft. The first in the market is Cloudera, captured more number of clients, then Hortonworks, then MapR. Okay, so coming to the Hadoop architecture, right? Hadoop architecture is in the form of master and slave nodes, right? So what is a master node? So we have a name node and secondary name node and job tracker is comes as part of the master node, and slave node are the data nodes, comma task trackers, right? So when I told that if you want to work with the Hadoop, right, first you have to load the data into SDFS, right? Your actual data resides in a data node, and the reference of the data in is maintained in a name node. Suppose you have a big text, you have a textbook where the textbook contains some 5,000 pages and you don't have the index, right? How can you find a particular topic, right? So the content is available in the book and the reference should be as an index, right? If you want to go for the particular content, first you have to check for the index. The same thing, the reference of the data is maintained in a name node and your actual data exists in a data node, right? The data physically available in the data nodes, and the reference of the data is available in a name node. So name node contains a metadata, or name node contains a file system tree kind of structure of the data or of the directories or the files which are available in data nodes, right? So this is Hadoop architecture. So if you are having 100 node clusters, means you can configure one node as a name node, you can configure one node as a secondary name node, and remaining 98 nodes you can configure it as a data nodes, right? So in the job, if you want to run a job, the job is taken by the job tracker and the job is executed by the task tracker, right? So anyway, in the coming sessions we'll dig deep into the Hadoop architecture, right? As of now, Hadoop architecture contains master and slave nodes. So name node, secondary name node, and job tracker comes as part of the master node, and the data nodes and task trackers comes as part of the slave nodes. So your actual data resides in a data node. The reference of the data is available in a name node. Suppose there are 100 rooms are there. Okay, you are searching for the person ABC, and XYZ is searching for the person ABC. So what you are doing, you have to go for room number 1, then you have to go for room number 2, then you have to go for room number 3, right? It takes a lot of time, right? Suppose there is a person Ajay is there. Ajay knows where the ABC available, right? So then XYZ goes to ABC, right, and ask the person where ABC available. Right, then Ajay says the person which you are searching is available in a room number 99. So XYZ goes to room number 99 directly. So here Ajay is a name node. The person who is searching for the XYZ is the job. Right, the person who you are searching is the data. Okay, so we'll discuss we'll dig deep into the architecture in our coming sessions. Right, so this is about Hadoop architecture, and this is about Hadoop distribution. Okay, so right, so here, so if you take Hive, we have Hadoop. This is a Hadoop environment, and we can use the two components with the GUI. Hue is from the Cloudera Hue, and you can monitor the clusters with the Cloudera Manager. Right, so this is a CDH4 environment. This is Hadoop from the Cloudera. We can use Hive, we can use Pig, Impala, HBase, and we can use the shell to write the jobs. Right, so we have a Hive shell and we have a Pig and program. Everything is predefined, configured, and given by the Cloudera. Right, so you can use Hadoop from the any distributions, or you can use Hadoop from the vendors. You can get it from Hortonworks, right? Just go for the Hortonworks, then download SDP. So you have to buy that one. So they'll give you the trial. So when you're actually, if you want integrate it for your project, so you need to contact them. So they'll come and they'll configure. So you have to pay for them, right? So you have to pay for the configuration as well. You have to pay for the support. Okay, so this is that my training content. In the chapter 1, we are going to discuss about, right? So what is introduction to big data? So where we'll discuss what is Hadoop, Hadoop components, Hadoop framework, Hadoop distributions, and how Hadoop can be implemented in retail, healthcare, telecom, etc. Right? So in the chapter 2, we are going to discuss about Hadoop distributed file system. So how SDF is designed, Hadoop file system, so Hadoop daemons, right? How we load the data into SDFS, how we use Java API to load the data into SDFS, how we perform the serialization. So we'll discuss in chapter 2. Right, in the chapter 3, so we'll discuss how to administer the Hadoop cluster. Here I have added a little bit Hadoop administration. So we'll discuss the complete Hadoop architecture. So we'll discuss Hadoop cluster specification. I'll show you how to calculate for the name node, how to calculate the data nodes, how to buy the storage machines, how to calculate the storage for this your cluster, right, and how to configure installations, right? Everything we'll discuss in chapter 3, where we'll discuss DFS admin, balancer, job tracker, task tracker, name node, right? Hadoop file system commands, right? This is what we have in chapter 3, administering Hadoop cluster, right? In the chapter 4, I'll show you the scoop. Scoop is a component where we get the data from the RDBMS. Right, I'll teach you the scoop, the complete scoop. So how to get the data from the Oracle, how to import the data from the Oracle, how to import the data from the Teradata, how to import the data from the SQL server. Both import and export we'll discuss in the scoop. Scoop is a component which is try to load the data between RDBMS to SDFS. Right, so you can transfer the data between RDBMS and SDFS. So the complete scoop I'll teach you in chapter 4. Right, in chapter 5, I'll teach you about Hive programming. So the complete Hive query processing, Hive security, how to create the tables, partitions, buckets. Okay, just a second, I'll come to clarify all your questions. Right, this is chapter 5. In the chapter 6, we'll discuss the pig. Right, I'll teach you the complete pig programming. Right, in the chapter 7, it's a map reduce. So I'll teach you what is a map reduce, map reduce architecture. So map reduce data types, how to write a map reduce job. I'll teach you the best way in how to write a map reduce program. I'll give you map reduce programs to practice. And so these are the things, how to write a map reduce job in Eclipse, how we are writing a word count program. So I have a different map reduce programs. So we'll learn the map reduce in chapter 7. Right, in the chapter 8, so we are going to discuss about yarn architecture. So the Hadoop before 2.0 and Hadoop after 2.0 is different. Hadoop before 2.0, we have a job tracker and task tracker. Hadoop after 2.0, this is yarn environment where we have a resource manager, node manager, application manager is available. So that we discuss the complete yarn architecture in chapter 8. Right, I have chosen MongoDB as part of the NoSQL programming. So in the chapter 9, I'll teach you what is a MongoDB, how to work with a MongoDB. Right, so this is chapter 9, we discuss MongoDB. In the chapter 10, I'll give you what is a zookeeper and how to work, how to write the MapReduce in Spark, and what is a brokerage or communication system with Apache Kafka. So this is chapter 10. I'll give you overview or introduction about zookeeper, Spark and Kafka in chapter 10. In the chapter 11, I'll teach you the job scheduling with Uzi and how to work with the edge base. So we'll discuss in chapter 11. In the chapter 12, it's a Hadoop cluster monitoring tools. I'll teach you how to use the Cloudera manager, how to monitor the health of the Hadoop cluster, how to identify the errors, bugs, right, I'll teach you in chapter 12, and I'll teach you Hadoop cluster monitoring with a tool Ganglia. So what is a Ganglia and how to use this tool, I'll teach in chapter 12, right? So I'll take 40 to 45 hours to complete the training, right? The session duration is 60 to 90 minutes and it's a 5 sessions in a week. I'll give the notes on each topic. Right, so I'll give you steps to configure Hadoop in your machines. So that's my role. I'll give you a link to download, and I'll if it's difficult for you, I'll take the control and I'll configure the Hadoop in your machines, right, so that you can simultaneously practice with me in your machine. Right, my sessions are completely practical environment. I will show you everything by executing in my machine. It's not like taking a PPT and explaining the content from the PPT. No, I'll take the environment, so everything whatever we are discussing, everything I'll show you by executing in the machine. So my sessions are completely practical and programming oriented. Right, I'll give the data sets and I'll give the programs to practice. Right, I will use the environments. I'll introduce the Hadoop from the Cloudera, Hadoop from the Huttonworks, Hadoop from the Mapper, and Hadoop only available from the Apache. So I'll use these environments in my training. Right, and see here, Mr. Anil, see, as per your question, is there any respective field whether it is fine to migrate Hadoop? One thing, the survival is easy in Hadoop, right? So would it be? Yes, I'll provide the recording sessions. For every session we'll have a recorded, so you will be get an access to a Google site where I'll upload the content and you have to subscribe that one. So every you'll get the recorded video sessions, you'll get the content, and if you are working, if you have any issue, simply just screenshot, then I'll try to correct the error. So you'll get a dedicated Google site page like this. So where the data is available, where the notes, everything is available, right? So you have to download the content, you have to download the notes. I'll provide you the record sessions, right? You will get the access to recorded videos for every session. Right, if you have any issue, any doubt, so you can raise your question here by writing an item, specify what is your issue here, right, specify the priority and write your issue and send it to me. Okay, so you'll get the Hadoop environment and you'll get the support while practicing with the environment. Right, so I'll give you the notes for everything whatever we discuss in the session. You'll get the notes. Right, uh, right, like this you'll get the notes for everything whatever we discuss in the sessions. I'll give you the notes. Right, so these are the notes. You'll get a clear detailed notes along with the screenshots. What are the best way to push? You can see, to load the data into Hadoop we have the components. Scoop is one component, you can use Flume is a one component, you can use WebSDFS. Through WebSDFS you can transfer the data into SDFS. Okay, so if you have any questions or any queries, please raise your hand. Otherwise you can write your question in the chat box. Okay, right? So I'm starting the new batches available. Uh, so we have the batches from 7:30 to 8:30 a.m. is one batch is available, and one batch is available from 8:30 to 9:30 a.m. and one batch evening, that is 8:30 p.m. to 9:30 p.m. is available. Right? You can join in any batch. Both are starting from tomorrow onwards. You can join in one batch, that is 7:30 to 8:30 a.m. in the morning, 8:30 to 9:30 a.m. in the morning, or 8:30 p.m. to 9:30 p.m. in evenings. Right? It's a based on IST time zone. So it's in EST, it's a 9 to 10 p.m. It's 10 to 11 p.m. in EST. We need to pay before joining, right? See here, yes, you have to you will initially you can attend 2 3 sessions, then can decide whether you want to continue with the session, right? Suppose you can ask for the refund too if you're not satisfied the way how we are how the training is going on. So within 7 days I'll give you the refund. If you want to pay full, you can pay the full amount. Otherwise, if you want to pay as you go, you can. Right. So my course fee, usually I'll take 15,000. Right. For this batch, I'm taking 12,500 as a training fee. Right. If you can pay, I'll complete 12,500 at one go. Otherwise, you can go for 2 terms, pay 6,000 initially. Then when we start discussing about the chapter 4 onwards, you have to pay remaining 6, as you can pay as you go, right? So 6,000 as a first term. So for the first 3 chapters, pay 6,000. So when I start this chapter 4 onwards, you have to pay remaining 6,000. Right, and you have a flexibility in my session. So the people who is working on the rotation shifts, so you can join any number of batches anytime. If you join with me in the training, suppose if it is not possible for certain days to attend the session, right? So can join any number of times. You can attend any number of sessions. Right, suppose you have completed the training and you want to learn hive, you want to attend the hive sessions again. So if you give a mail, then I'll send a link whenever I start the hive in the next batch. Right, so you have a flexibility. You can join any number of times, you can join any number of sessions. There is no limit, there is no time limit, there is no limit for the number of sessions. Okay, so you can make the payment through debit card, credit card, net banking, or bank transfer. Everything is, it's possible. If you want to pay through credit card, yes, I'll accept the payment through credit, debit, and net banking is available. Right. So if you have any queries regarding the training, then you can write a mail, Hadoop framework at gmail.com. You can send a mail with your queries and questions to my Gmail. It's Hadoop framework at gmail.com. You can see this is my website, beinghadoop.com. Okay. So I'll send you a link for the available sessions to your Gmail. So if you want to go for the morning 7:30 batch, please register for the session 7:30 to 8:30 a.m. If you want to go for 8:30 to 9:30 batch, so please register for the link 8:30 to 9:30 a.m. If you are looking for the evening batch, you can register for the link 8:30 to 9:30 p.m. So if you are looking for the weekend batches, so I'm going to schedule very much soon the weekend batch, so you can join in that batch too. So it's a 4 weekends I will have, right? So if you are looking for any specific timings, please you can write to my mail by available times for you to take up the session.